today's discussion will be focused on division of polynomial. I have done videos on addition, subtraction, multiplication, and degree of a polynomial. I'll request you go look for those videos. Now let's discuss quickly division of polynomial. Now if we have this and you're asked to divide, for instance, here is SQ. We have SQ plus 2x squared minus 5x minus 6 all over x minus 3. Now I want you to understand that once you have an expression like this, of course this is what your typical fraction is, a fraction, and so the numerator of this fraction, this is of course the numerator, and this is the denominator. In polynomial, the numerator is called the dividend. We call it the dividend, while the denominator is called the divisor. Now, when you divide, in other words, when you whatever the divisor or the denominator is, the number of times it divides the dividend or the numerator, that becomes the quotient. I'm trying to tell you that once you divide the dividend all over divisor, of course you have an answer. That answer will either be the number of times the divisor will divide the dividend and then the remainder. So we're going to have what? The quotient. The quotient in this case represent the number of times the divisor will divide the dividend. And then we expect to equally have what? A remainder. Sometimes there may be no remainder, and if there is no remainder, then the remainder is 0. This is similar to if you say 5 divided by what? 2, for instance. 5 divided by 2, you know that this is the numerator and this is the denominator. This numerator, in this case, we said it's what? The dividend. And then the denominator, in this case, is what? The divisor. By the time you say 5 divided by 2, you know that it's going to be what? 2 times. That 2 times in this case is what? Our quotient. Now of course 2 will divide 5 2 times, and it will, the remainder will be what? 1. So the remainder still remains what? The remainder. So supposing you have, for instance, 10 all over 5. Here in this case, of course 10 is a numerator, 5 is a divisor, denominator. How many times will 5 divide 10? Of course, it will be what? 2. The quotient is still what? 2 in this case. But in this case, the remainder is equal to what? 0. Here, the remainder is 1. So, what I'm simply telling you is that when you have a fraction, when you have a polynomial that is to be divided by what? Something else, another polynomial. Remember that this is a polynomial, this is also a polynomial. There are 2 polynomials. One is the numerator, the other is the denominator. The one that is the numerator is called the dividend. The one that is the denominator is called the divisor. When the divisor now divides the dividend, the number of times it does that is called what? The quotient. Whatever that is remaining, it's what? The remainder. Like I said, sometimes nothing may remain, and when you do not have any remainder, then you say remainder is 0. Okay, let's quickly take example. Supposing we want to divide this, let's say if the question is divide assuming we have this and we want to divide it, what do? The division is similar to when you're dividing 5 all over 3. You will agree with me that if you're dividing 5 all over 3, what you do is you do this and then the 5 will be here. That means here it's always what? The numerator, while here is the denominator. Of course, it means that the 5 will be here and then the 3 will be here. The same thing that applies to here. So we relate that understanding to what we have here. And so if I do this, this will be the numerator. Here, of course, we say the numerator, and this numerator is what? We said it is called what? The dividend. And here we said this is the denominator, and of course this denominator is what? The divisor. So it means that we will have here our divisor. In this case, the divisor is x minus 3, and the dividend, which of course is the same as the numerator, is what? X raised to power 3 plus 2x raised to power 2 minus 5x minus 6. Now, for 5 all over 3, what you will always say is 3 into 5. In other words, how many times 5 will divide 3? Of course, you will say it is 1. But in this case, because you're not dealing with numbers, you're dealing with variables, with letters, what you need to do is to ask yourself that what is the degree of this dividend, and what is the degree of this divisor. I've done a video on degree of a polynomial, which is why I asked you to search for that video. So now, if you are to look at this, if you consider the dividend, ask yourself, what is the highest power? The highest power will of course represent the degree. The degree of a polynomial simply refers to the highest power of the variable that is contained in that polynomial. And we have x here, we have x, all through we have x. This x has power 3, this x has power 2, this x has power 1. Of course, 6 has an x, but that x is raised to power 0. So if you compare the power of this x, the power of this x, the power of this x, and the power of this x, you'll notice that the power of this x is the greatest, and which is of course 3. And because the highest power here is 3, we now say the degree of this dividend is what? 3. How do we get that 3? What helps us? What is the term that has the 3? This is the term that has the 3. The first term. Of course, you should know that this is the first term, this is the second term, and this is the third term. Of course, this is the fourth term. For the divisor, we have only 2 terms. This is the first term, this is the second term. Now for the divisor, if I asked, what is the degree of the divisor? The divisor is x minus 3. I want you to know that 3 there is x there, though invisible. If I'm to bring in x will be raised to power 0. So that x raised to power 0 will be 1. 1 times 3 will remain what? Will be the same thing as what? Minus 3. And so it means that if this x is raised to power 0, if this x is raised to power 0, and this x is raised to power 1, therefore means the highest power of the divisor is 1. And that 1 is determined by what? This term. The 3 here, the degree here, is determined by what? This first term. Why am I emphasizing the term that gives the degree? I'm emphasizing that because if you're dividing this dividend, what you're going to do is you use the term of the divisor that determined or that gives the divisor its degree. You use it to divide the term that gives the dividend its degree. In this case, the term that gives the divisor its degree of 1 is this term. Why does the term that gives the dividend its degree of 3 is this term? Therefore, I will be using this to divide this. I will now say x into x raised to power 3. That's simply x raised to power 3 all over x. And of course, you know that this is x raised to power 3, this is x raised to power 1. Second law of indices. This of course will be equal to x 3 minus 1, and that will be x raised to power 2. Or simply say x cancel 1 here and x cancel another there, and that you'll be left with what? X raised to power 2. Therefore, that x raised to power 2 has to be written here, x raised to power 2. Remember, when we are using numerals, the moment you say 3 into 5, you say it is 1 time. That 1 is written up here. That's the same thing we have done here. The moment we say x into this, it is x raised to power 2. That x raised to power 2 has to be written up here. The same way we do when we are dealing with what? Numerals. When we are dealing with numerals, what do we do? The moment you have written this one here, what do? You say 1 times 3, and that will give you what? 3. The same thing I'm going to do here, because here we have x raised to power 2. The x raised to power 2 will therefore multiply this, just like this one multiply this 3. And then x raised to power 2 multiplying this, that will give us what? X raised to power 3. Again, At this point in time, the x raised to power 2 must multiply every thing that makes up the divisor. Even if this divisor, in this case, our divisor has only 2 terms, this term and this term. Supposing it has 4 terms, it doesn't matter. This must multiply every component of the divisor. So in this case, I'll say x squared times x, here will be x cubed. X squared times minus 3, that will give us minus 3x squared. You know that the divisor has 2 parts, which is the first term and the second term. So I have used x squared to multiply the first and second term of what the divisor. I haven't done so. We'll go back here. Remember, I tried to compare division of numerals and division of polynomials. Because with numerals, it's simple. Now, for numerals, the moment you say 1 times 3 and you say the answer is 3 and the 3 is written here, what do you do next? You draw this line here, the division line. And once you draw the line, what do you do next? You subtract by saying 5 minus 3. And 5 minus 3, of course, will give you what? 2. The same thing will be applied here. The moment we have used this to multiply the divisor, this became our answer. The next thing we're going to do is to draw this line. Haven't drawn that line, the next thing I'm to subtract. Again, knowing too well that in this case, when you're subtracting, you must ensure that the first term disappears. Whatever sign you're putting here, because in this case, your sign here, you may decide to add, you may decide to minus. What determines what you're to do to these two? This is now a polynomial, this is now a polynomial. What will determine whether it's a plus sign or a minus sign will be what will turn s cubed to 0. In other words, s cubed must disappear, the first term. So I will now say, if I put a plus sign here, s cubed plus s cubed, of course that will be 2s cubed. So s cubed will not disappear, will not become turned to 0. For s cubed to turn to 0, then there has to be a minus sign. There has to be a minus sign. Why am I emphasizing this? Supposing this s cubed was minus and this s cubed was minus. Of course, in this case, I will still put a minus sign because it is a minus sign that will turn the s cubed to 0. What if this is a plus? What if this is a plus and this is a minus? If I put a minus here, s cubed cannot turn to 0. You cannot see. It will be minus s cubed minus s cubed, and the answer will be minus 2s cubed. The idea is that after you must have used this to multiply the divisor, whatever you have here, you must now decide a sign, either a plus sign or a minus sign, depending on the one that will lead to the elimination of the first term, which is, of course, that's why you see the term here must have the same power with the one that is below it. So I will therefore go forward a minus sign, because a minus sign will give me what? 0 of what? S cubed. So I will now say s cubed minus s cubed, that will be what? 0. At this point in time, I will now say, look at this is s squared and this is s squared. You notice both have what? The same powers. That means they are like terms. You do not subtract or add terms that are unlike. That's why we say s cubed minus s cubed, because they are like terms. This one now, 2s squared, and this is 3s squared. They are also like terms. So what do? I will say 2s squared, which is this one, minus, which is this minus, which is this minus, 3x squared. Now when you open up the bracket, that will be what? 2x squared plus 3x squared. Of course, this will become 5x squared. And then you put your answer here, 5x squared. What I'm saying in summary is that 2x squared minus 3s squared. The answer will become what? 5x squared. Now you look at this one. This is minus 5x. Minus 5x do not have a like term here on this line. You know that this polynomial has only this and this. I'm taking time to explain this first example because I'm using this to explain everything about what division of polynomial. If you have understanding of this very question, you can address any question given to you. Now, minus 5x should be subtracting a like term. But if you look at on this polynomial, we've already subtracted this, there is nothing else here to subtract. Some people will tell you bring down minus 5x, but that is not scientific. That's not scientific. Bringing down doesn't really mean anything. So, but the reason why you're bringing down is this, is because there is a presence of x here. If I'm to bring x here, what I'm going to bring will be plus 0x. That's what I'm going to. Well, that it means that the coefficient of the x I'm bringing is what? 0. So I will now say minus 5x minus 0. That will give me minus 5x. It's more scientific that way than saying bring down what? Minus 5x, as some students are used to that. Then you count, the same thing happens to minus 6. Remember that minus 6, though does not have what? X. But there is an x there. If I'm to bring in x, that x will be what? X raised to power 0. Because x raised to power 0 is 1. 1 times minus 6 remains minus 6. So again, minus 6 here does not have, there is no like term here. It means that the like term here, I've just told you that minus 6 is the same thing as minus 6 x raised to power 0. If I have to bring the like term here, the like term here will be what? 0 what? X raised to power 0. You cannot see that 0 x raised to power 0 is like nothing at that, nothing is here, because x raised to power 0 is 1. 1 times 0 is 0. That means there is nothing here. So I have not changed anything. So if I now say minus 6 minus this 0, my answer will now be minus 6. Which is why people will tell you bring down minus 5x, bring down minus 6. Now, at this point place, you cannot see, you'll notice that here we have the power of x squared, and here the power here is what? 1. If I ask you what we now have at this point, do we have to stop here? Do we end the problem here? No. You can only end the problem at the point or at the stage where the degree of the new polynomial is less than the degree of what? The divisor. It's like the number now. Because 3 into 2, I know that 2 is smaller than 3. And so 2 cannot divide 3. If I say 3 into 2, of course you will say it cannot. The reason is that 2 is smaller than what? 3. But for numbers, the moment you say 3 into 2, you say it cannot. For you to continue the division, you will have to introduce a decimal point there, and then with the introduction, as you introduce the decimal point, you have the permission to add 0 here. But we don't do that here. For polynomial, once you get to a point where you can no longer divide, you will stop at that point. For numerals, you can continue by what? The introduction of what? A decimal point at this point. Okay, now how do I know? In this case, how do I know that this number, this expression is smaller or greater than this one? Again, the degree. I ask myself, what is the degree of this? The degree of this one is 2. Of course, you know that the highest power here will be 2. And because it's 2, I will ask myself, what is the degree of the divisor? The degree of the divisor is 1. 2 is greater than 1. I will continue to divide. You only stop dividing when the degree of whatever you have here is less than the degree of what you have here as for the divisor. So because this is a degree 2 and this is degree 1, it means that the degree here is greater than this degree. And for that reason, I have to continue the division. I will now say x into 5x squared. Know that is the same thing as saying 5x squared all over what? X. This will be 1 and there will be 1 off here. This will be what? 5x. So the answer will be plus 5x. Now I have written plus 5x. I will now use again this plus 5x times this. That will again give us 5x squared. Remember, just notice one thing. Once you use anything here to multiply here, the very first answer you're getting must have the same coefficient, the same degree, such that you can easily eliminate them. You can see that this is the same as this. Once I see that I'm not having the same thing, then I might be wrong. So when I say plus 5x times this, that will give us 5x squared. 5x times this, that will give us minus 15x. Again, I will have to draw this line. So So again, like I said earlier, what do? We have to ensure that this turn to 0. I can't possibly put a plus sign here because a plus sign will give me 5x squared plus 5x squared, and of course that will be 10. I would rather introduce a minus sign because 5x squared minus 5x squared will give me 0. And then you now have here minus 5x, which is this one, minus, which is this minus 15x. See what I have? Then this will be minus 5x. This minus times, of course, will be plus 15x. And then when you this minus 5x plus 15x, that will give us plus 10x. So what we'll have here will be 10x. Minus 6 minus 0 here, like I did earlier, that will give us minus 6. Again, at this point, I will ask myself, what is the degree of this? You can now see that the degree of this is 1, while the degree of the divisor is still 1. So we continue to divide. You can only stop to divide when the degree of whatever you have is less than the degree of what? The divisor. So I will now say x into 10x. In other words, 10x divided by what? X. The answer, of course, will be what? Plus 10. So I'll come here and write plus 10. 10 times this will give me 10x. 10 times minus 3 will give us minus 30. And then introduce your minus sign. 10x minus 10x, of course, that will be 0. Then you have minus 6 minus 6 minus 30, of course that will be what? That of course will be minus 6 plus 30, and that will be what? 24. Now 24 is the same thing as 24x raised to power 0, because if you write it 24x raised to power 0, it is the same thing as 24, where x raised to power 0 is 1. 1 times 24 will still give you what? 24. So you can now see that. Why do I choose to write it this way? Because I want you to understand that at this point we're having a polynomial that has degree 0. You can see the degree is 0. And because the degree is 0, the divisor degree is 1. And I've said anytime the degree of whatever you have here is less than the degree of the divisor, then you will not continue to divide. So at this point, I cannot continue to divide. I will not introduce a decimal point as in the case of what? Numerals. So you simply stop dividing at that point. Now, you will now say that now from here, it means that our remainder, what this means is that our remainder is 24. It means our quotient is equal to, remember our quotient is equal to x squared plus 5x plus 10. That's our quotient. If you are to represent it the way it should be, you have it this way, that x raised to power 3 plus 2x squared minus 5x minus 6 is equal to, you have the divisor is x minus 3, you have the dividend, which is so after you're done solving, this is how you may express your answer. You know, there are sometimes, depending on the question, the examiner may be interested in what? The quotient. For instance, you have the question, what would be the quotient if this is divided by this? Then you look at the options, and then you find this to be in one of those options. Supposing this is an essay, an objective exams. They may say, what will be the remainder when this is divided by this? The same thing, you look at the option. But if it's an essay exams, that means you have to show all of this. At the end, you express your answer this way. You say this is it. You say your f of x, of course, f of x is the given polynomial, is equal to the divisor d plus, times the quotient q, then plus the remainder. So in this case, we have our f of x was given to us as what? X cubed plus 2x raised to power 2 minus fx minus 5x minus 6 equal to, what was our divisor? Divisor is x minus 3. Our quotient is x squared plus 5x plus 10, then plus the remainder, 24. So if it's an essay exams, this is how it should be expressed. But if it's an objective exams, the examiner may be specific. Either is interested in the remainder or is interested in what? The quotient. Already, the examiner must have given you what? The dividend as well as what? The divisor. Now, supposing we have another example. Let's take another example. This is another example. Here we were asked to divide x raised to the power 4 minus 81 all over x squared plus 3x minus 1. Again, you see here, our divisor is x squared plus 3x minus 1. Our divisor has 3 terms, while the dividend has 2 terms, making it look as if the divisor is greater than the numerator, the dividend. It's not true. Remember that you judge based on the degrees. The degree of the dividend is 4. The degree of what? The divisor is 2. That tells us, or that shows that the dividend is greater than the divisor. Supposing the divisor was the numerator, then we cannot divide that expression. It is not divisible. Because it's like saying 3 all over 5. 3 all over 5, you say 3 divided by 5. Of course you say it cannot. It's not, because of course 5 is greater than what? 3. So in this case, this is greater, numerator is greater than what? The denominator. So it means that you must ensure that your numerator is always greater than what? The denominator. Now let's quickly look at that question. As usual, we draw this, and then this of course should be the position of what? Our dividend, which is what? X raised to the power 4 minus 81. While here it's what? X squared plus 3x minus 1. Like I said earlier, what you need to ask yourself is that what is the degree of what? The dividend. The degree of the dividend in this case is 4. 4. Why is it 4? Because the highest power here is 4. Of course, the dividend has only 2 terms, this and this. Why this one has x raised to the power 0? Because there is no x here. It tells you that x here is raised to the power 0. Because if x is raised to the power 0, that becomes 1. 1 times minus 81, it remains minus 81. It doesn't change from what was given. Therefore, the degree of this is 4. What makes it 4? Because of what? The first term. I'm emphasizing because you need to know the term that gives that's responsible for that degree 4. That term is the first term, which is why I've written it first like this. I didn't place it here and take this one first. No. Now for the divisor, what is the degree? The degree is 2, and you see that 2 was given by this term, the first term. So what I have to be doing is to use the first term of this divisor to divide the first term of what? The dividend. You must always use the term that determines the degree of the divisor to divide the term that determines the degree of what? The dividend. That's just the principle. At that point, because of that, I will now say x squared into x raised to the power 4. What that means is that I will say x raised to the power 4 divided by what? X squared. That, of course, you know that is x 4 minus 2, and that will be x raised to the power 2. Or you simply say x times x times x times x, and this is x times x. Where this will cancel, you're left with what? X times x, which is x squared. So now x squared into this is x squared. Now that x squared is written up here. X squared times this, that will give us x raised to the power 4. X squared times plus 3x, that of course will give us plus 3 x raised to the power 3. X squared times minus x, that will be minus x squared. Of course, you know that anytime you have gotten what is here, you have to use it to multiply everything that make up what? The divisor. So at this point, as usual, I will draw this line. And the next thing I will do is to subtract. I'm subtracting because subtraction will lead to the elimination of x raised to power 4. I told you this first term must turn to 0. Therefore, for it to turn to 0, I have to put a minus sign there. So that x raised to power 4 minus x raised to power 4, I'll have 0. Then you look at the next term here is x raised to power 3. If you look at this other line, there are two lines here, this one and this one. I have used this one on this line to subtract this on this line. The next supposed to be x raised to power 3, but there is no x raised to power 3 on this line. It means that the x raised to power 3 on this line or on this dividend has a coefficient of 0. If I'm to introduce it, this would have been 0 x raised to power 3. I will give it a coefficient of 0. So that 0 times x raised to power 3, it will turn to 0. Because already originally there was no x raised to power 3 there. So whatever I'm bringing must be such that if you convert it, it will disappear. It will not exist there. Which is why I am putting 0. If I say 2x raised to power 3, I have introduced something that wasn't there from the beginning. So you can now see that having introduced 0, it means therefore that 0 minus plus 3x cubed. That will give us simply what? Minus 3x cubed. That is 0, this 0 minus 3. Since the coefficient is 0 and 3, why the x cube is here, x cube is here, so 0 minus 2. That's why I said go and check my video on addition and subtraction of polynomial. I took time to explain all of this because this is simple addition and subtraction of polynomial. So x 0 minus this will give us 0 minus 3x cube. Again, look at s square here. For this x square, there is no s square on this line. So if I'm to introduce s square, I'll equally say plus 0x square. And having done so, this 0 minus this, that will give us plus x square. Then minus 81 minus 0 here. There is no 81 here. There is no number here that has no x. So it becomes minus 81 minus 0 there. That will be minus 81. That's what you say break down. Some people will tell you bring down. You see. So at this point, I'll ask myself, do I stop here? I told you can only stop here if the power here is less than the power of the divisor. But what is the power of our divisor? The power of our divisor is what? X raised to power 2. Why the power at this point is power 3? That means we have to continue to divide. So I will now say x squared into, that's to say minus 3x cubed all over what? X squared. Of course, that means x squared will cancel out what? Another x squared here. Of course, you know that this is the same thing as what? This is the same thing as minus 3 times x squared. That's the same thing all over now x squared. This x squared will cancel this. You're left with what? Minus 3x. That minus 3x will be written here minus 3x. The moment it's written here, you use it to multiply everything here. And once you do that, this becomes minus 3x times this. That will be minus 3x raised to power 3. Minus 3x times this, that will give us minus 3. Minus 3x times this will give us minus 3x cubed. Minus 3x times this, of course, minus 3 will times the 3 here, that will be minus 9. Of course, minus 9. The x will times the x, that will give us x squared. And then minus 3x times minus 1, that will give us plus 3x. Because minus will times the minus, that will turn to plus, and then you have 3x plus 3x. And then at this point again, you draw this line, as we have always done. Again, I told you, after you have used whatever that is here to multiply, whatever, you must now decide a sign that will eliminate this first term. So I will now begin to ask myself, what sign? If I use a plus sign, this x cubed will not turn to 0 because the answer would rather be minus 6x cubed. So I would rather introduce a minus sign, because a minus sign will give us minus 3x cubed minus 3x cubed. Of course, that will be what? Minus 3x cubed plus 3x cubed, and that will become what? 0. So this automatically will turn to 0. Now, how about s squared? S squared here, remember, there is an invisible one here. That will give us, this is x squared minus 9x squared. Of course, that will be what? X squared plus 9x squared. That will give us what? 10x squared. So what we're going to have here will be what? 10x squared. You have here 10x squared. I'll take that again. X squared minus 9x squared. X squared, that's what I've written here. X squared minus, this minus is this minus, into a bracket of what? This minus. This minus is this one. Then 9x squared. Now this minus will multiply this minus. Of course, it will turn to what? A plus. You bring this one here, and this will come here. At the end, you see that this is x squared plus 9x squared. That becomes what? 10x squared. And the 10x squared is written here. Again, here is x. There is no term here with what? The power of x. This is x raised to power 1. There is no term because after x squared, we're supposed to have x raised to power. We were supposed to have x raised to power 1 because these things are arranged in order of what is descending order of powers. You see, here is 3, here is 2. The next supposed to be what? Power 1. But there is no power 1 here. And because there is no power 1 here, if I'm to bring it as I did the other time, I would have simply say 0x. 0x, if I'm to introduce it, it's extraneous because it was not there. So if I'm to introduce it, I will introduce it with a coefficient of what? 0. With the coefficient of 0, it means it doesn't exist because 0 times x will be what? 0. And 0 plus this remain there. So nothing is as good as not existing. But I'm introducing it for because I want to explain, use it to explain how we can subtract this 3x. So we can now say 0 minus plus 3x. That will give us minus 3x. Now minus 81 minus, of course, here will be plus 0 because there is no, on this line, on this polynomial, there is a number 8 minus 81 that doesn't have x. Even if there is x, the x is raised to power 0. But on this one, there is no number. So you put it that the number is there is 0. So you now say minus 81 minus 0. That will give you what? Minus 81. And some people will tell you, bring it down, but it's minus 81. Now at this point again, you ask yourself, am I to stop dividing at this point? You look at it carefully, you see that the power, the highest power here is 2. The power here is also 2, the highest power. And I told you, you can only stop dividing when the power, the highest power here is less than the power of the divisor. But in this case, it's not like that. The powers are the same, so we'll continue to divide. So we now say 10x squared into 10, x squared into 10x squared. That's to say 10x squared divided by what? X squared. Of course, the answer will be what? 10. Now that's what I'm trying to say is 10x squared all over what? X squared. Of course, this will cancel. You're left with what? 10. That 10 has to be written here. Of course, anytime you write something up there, that thing must be used to multiply the component of the divisor. I will now say 10 times 10. 10 times x squared. That, of course, will be 10x squared. 10 times this, of course, that will be what? 30. 10 times 3x, that will be 30x. 10 times minus 10, minus 1 will be minus 10. You draw this line. Again, what do? We subtract because we want to make sure that this x squared become turn to 0. We introduce a minus sign. And now 10x squared minus 10x squared, the answer will be what? 0. Now you now have minus 3x minus plus 30x. Of course, that will give us what? Minus 33x. Minus 81 minus, this is minus 81 minus, which is this minus this, and then minus 10. Minus 81 minus, which is this minus 10, which is this minus, and then that will be minus 81 plus 10. Of course, this is as good as what? Minus what? 71. Of course, these two will subtract, and then the greater number has a minus, and that will be minus 71. So we're going to have minus 71. Now, you ask yourself again, what is the power of this? The highest power of this is what? 1. Because the power of the 71 is x raised to power 0. And this power of this term is x raised to power 1. So the highest power is power 1. Now when you go to the divisor, the highest power is what? 2. Because the power at this point is less than the power of the divisor, you will stop to divide at this point. The division automatically ends. In fact, that is what informs where to stop your division. Otherwise, you continue to divide this thing. So you can only stop to divide at the point where, because at each of these stages, you can consider that this should be your remainder, but it is not. It is still being divided by the divisor. So at this point, nothing can divide. The divisor can no longer divide it. So if I'm to say this divided, I will say cannot. And you cannot introduce a decimal point as we used to do for numerals. So for that reason, you will stop your division at this point. If it's an essay exam, like I said before, you now express your answer the way I have shown you earlier. And you say that your answer is f of x is equal to, we say, to be divisor times the quotient plus the remainder. In this case, what is our f of x? Our f of x, of course, is the dividend. F of x is the dividend. It is x raised to the power 4 minus 81. It's equal to, the divisor is x squared plus 3x minus 1. Now multiply the quotient. What is our quotient? The quotient is x squared minus 3x plus 10. What is our remainder? Plus, our remainder is minus 33x minus 71. This is now the final answer. You know, what this simply tell you is that if you multiply this bracket with this bracket and then add it this, you get back this. That's what is that's how you can possibly confirm if you're correct. You can confirm if you're correct by simply doing what? Multiplying the divisor with the quotient, add the remainder. The answer should be what? Equal to the f of x or the dividend. If it is not, then you were wrong. So at this time, that's how you're going to end. That's how you approach division of polynomial. It's simple. So in case you have any, I want to believe you have understanding. But if you have any question, please drop them out at the comment section. Don't fail to subscribe to this channel. Don't also fail to like as well as share this video. Like I told you earlier, please try as much as possible to watch videos, my previous videos on addition and subtraction, as well as multiplication and degree of polynomial. Thank you.